All right, let's look at the homework 4.3, problem number 5. All right, so we have this function x times e to the 4x, and we want to find the interval where function is increasing and also decreasing. All right, so let's do that. All right, so we have to find the derivative. So f prime of x is equal to, alright, we're going to use the product rule. So x is the first guy, e to the 4x is the second guy. Alright, derivative of the first is 1 times second, e to the 4x, plus first guy is x, times derivative of e to the 4x is e to the 4x, but you have to multiply by derivative of 4x, which is 4. Alright, so this can be simplified to, right? So you have x to e to the x e to the 4x is in common, so pull it out. So e to the 4x, and then what's left is going to be there's a 1 here from the first term, and then there's going to be 4x from the second term, so plus 4x. All right. So this is the first derivative, and we set this equal to 0. So you can see that we can make 1 plus 4x equal to 0. So x equal to negative 1 over 4. All right. So that's the critical number. So we can do increasing, decreasing analysis using the number line here. All right. Tick marks is at negative 1/4. Right. Then we can just look at the sign of f prime. Right. So we can try anything less than negative 1/4. So I'm going to try negative 1. Alright, so if you try negative 1, if you put negative 1 here, it's going to be negative, and e to the 4x is always positive. So this guy is always positive, so this is negative, so it's going to be negative here. Alright, we're going to try anything bigger than negative 1/4, so I'm going to try 0. 1 minus 0 is going to be positive, so everyone's positive. So we have that. Right, so we know that the original function is decreasing before negative 1/4 and increasing after negative 1/4. Right, so let's type it in. Right, so it's increasing after negative 1/4, so it's going to be a negative 1/4 to positive infinity. Infinity. Right, so and decreasing before that, so it's a negative infinity to negative 1/4. All right, so we have that. All right, let's check the answer. All right, I came back and looks like we got the part A correctly. All right, so let's move on to part B. Local max and the local minimum value. All right, so it looks like that. And since it's the dips in the middle, so we know that we're going to have a local minimum. And here, oops, we're going to have, maybe I'll do that here. You have a local minimum there. All right, and it looks like we don't have a maximum there. All right, so we're going to have a local minimum at the negative 4. Actually, we have to find a value, right? So we have f of negative 1/4, right? So this is going to be, plug it in, negative 1/4, and then you have e to the 4 times negative 1/4 is negative 1. So it's actually negative 1 over 4e, right? So let's type it in. All right, minimum value is negative 1 over 4e, and then maximum value does not exist. All right, let's check the answer. All right, I came back and looks like we got part B correctly. All right, so we want to find the inflection point and the concavity. All right, so let's do that. All right, so we need the second derivative, so we're going to take the second derivative here. So f double prime of x is equal to, all right, so we're going to have, so this is our first guy, this is our second guy. So derivative of the first guy is 4 times e to the 4x plus, first guy is 1 plus 4x, and then times the derivative e to the 4x times 4. All right, so we're going to just do the same thing as before. So first I'm going to pull out here, 4 is in common. So I'm going to put the 4 here. All right, then e to the 4x is also in common. So I'll circle e to the 4x here and e to the 4x here. And I'll just probably put it here, e to the 4x. All right, then what's left is going to be 1 from the first term, and then plus 1 plus 4x from the second term. Right, that takes care of every one. Right, then we can clean it up a little bit here. So 4e to the 4x. Right, 1 plus 1 is 2 plus 4x. Right, but it's even, so I'll pull out the 2 also. So it's going to be 8e to the 4x. And pull out 2, you get 1. Pull out 2, you're going to get 2x. So if you set that equal to 0, we're going to have, right, so this part right here is always positive, so we cannot get 0, but we can make that guy equal to 0 to get the x is equal to negative 1/2. Right? So, inflection point is going to probably happen there, but we just need to make sure. Right? So here's x, and tick mark is at the negative 1/2, and then we look at the f double prime. Right? So we can try anything less than negative 1/2. So I'm going to try negative 1. So if you plug in negative 1 here, 1 minus 2, so that's negative. So we know that it's a negative sign here. And then if you try anything greater than negative 1/2, I'll try 0. If you try 0, that's going to be positive. So you have a positive second derivative. So we have original function concave down before negative 1/2. After that, it's going to have a concave up. All right, so we definitely have a inflection point there. Concavity changes there. So we just have to find the corresponding y value. So f of negative 1/2 is going to be, plug it in, negative 1/2. And e to the 4 times negative 1/2 is negative 2. So this is going to be negative 1 over 2 e to e squared. All right, so inflection point, let's see, so we're going to just plug it in. All right, inflection point is negative 1/2, comma, right, negative 1 over 2e squared. All right, and let's see, is that right? 2e squared, right? Right, so you just plug it in here, right? So we have that. And then concave up, starting from negative 1/2, and then all the way to positive infinity. And then, and concave downward is from negative infinity to negative 1/2. All right. Let's check the answer. All right, I came back and looks like we got the part C correctly. All right, that's it. I hope that this was clear.